1.1. Myself, Dr. David, Assistant Professor, Department of Electrical Engineering. My area of specialization is power electronics and drives. So the main object of today's session is we will try to focus on two things. One is how to identify the controllability of the electric drive and also how to identify the reliability. I will try to explain, I will try to focus on these two parameters, controllability as well as reliability of the electric drive, particularly EV application. Right? Before that, see, first 15 to 20 minutes I will try to concentrate on fundamentals. Once you get clarity on the fundamentals, understanding the advanced concept, it is not a difficult. Before that, I need to ask one question, important question. Why electrical drives are in circuit shape? Why all are in circuit shape? Motors, generators, all are dynamic machines, right? Why we need to apply sign? Anyone? Particularly for electrical scholars, sign is a reference. We don't have any option, right? Sinusoidal signal is reference for electrical scholar. When it is operating in motoring mode, forcefully you need to apply sinusoidal mode. Whenever it is operating in generating mode, you need to take care about the nature of the generated voltage. It should be sine shape. Now, question is there any alternative name is there for sign? Any alternative name? There is a name is there, technical name is there. Sinusoidal. Anyone? Sine is nothing but circuit. You know, sine nothing but circuit. Right? The beauty of, say, if mechanical system is in circuit shape, automatically centrifugal forces acting on the dynamic system is very less. Right? Heating effect is very less. If heating effect is less, advantage is you can operate more period. Otherwise, if extra cooling mechanism is required if it is not in circuit shape, right? So to minimize the heating effect or to minimize the centrifugal forces acting on the rotor surface, intentionally all dynamic machines forcefully they will make in circuit shape. Once your core is in circuit shape, you don't have any other option. You need to arrange the conductors in the circuit shape. Once conductor is rotating in circuit shape, generated EMF is alternate. Example, let us assume that take this one, north pole, south pole, right? This is the nature of flux path. Flux is passing from north pole to south pole. Assume that conductors are rotating in circuit shape. There are two things happen. One is stator, another one is rotor. Right? So here, case 1, I will take reference person on the stator side. If reference person is sitting on the stator side, irrespective of the time, right, the nature of the vector is looking like constant. Got my point? If reference person is sitting on the stator with respect to stationary person, the nature of the flux produced by the north and south pole is looking like constant, Tc. But if you take reference person on the rotor side, right, the nature of the vector will change. Assume that this is this is a straight line. With respect to you, this vector length is almost 20 to 30 centimeters. If I stand here with respect to me, it is looking like dot. If I go there, the length of the vector it will increases. Later, if I go exactly perpendicular to the vector, the length of the vector is maximum. Right? If you complete one cycle 360 degrees, the nature of the vector is sinusoidal. Clear? So final conclusion is sinusoidal nothing but less stress on the core. Right? Heating effect is less, reliability is more. That's why for electrical scholars, sine is a reference. Next, one more important thing is what is the need of control mechanism, whether it is electric drive or even if you take your application, any application. Now, what is the primary object of the control system? Anyone? What it will do exactly? Anyone? What is the need of control mechanism? Whenever you want to control something, what information is required? See, I will try to expand fundamentals initially. Later, I will try to focus on advanced control system. See, whenever you want to control electric drive, important thing is you should know characteristics of the actual system. How to extract the characteristics? Looking for electrical qualities. For each and every system, we have mathematical support. Based on the mathematical equations, we can extract the characteristics of the system. We can easily identify what is the order of the system. Based on the order, we can decide whether controllability is simple or whether controllability is complicated. We can easily decide based on the characteristic equation of the system. Now, one more important thing is how to identify the characteristics. Example, take students. See how we can judge the student characteristics based on the CGPA. We don't have any option. Please try to understand. As a teacher, CGPA is the only parameter to decide the student characteristics. Right? Whether student is good or topper or average student, we can decide based on CGPA. CGPA is the expected output of the student. So similarly, whenever your drive is operating in motoring mode, what is the expected output? What is the expected output of the electric drive is operating in motoring mode? Drive can operate in motoring mode as well as generating mode. If drive is operating in motoring mode, what is the expected output? See, for students, CGPA is the output parameter. Based on the output parameter, we can decide the characteristics. Whether the student is good or average or below average, we can decide. Now, take motor. What is the expected output of the motor? What is the function of motor? Anyone? Basically, motor is a torque producing device. Whether it is a DC motor or AC motor or special machine or multi-phase machine, basically all motors will produce expected output is torque. So, in today's session, I will try to focus, initially I will try to focus on how to extract the mathematical model for particular system using torque profile. Based on the torque profile, we can easily identify whether controllability of the drive is simple or not. If controllability is simple, you don't need to adopt advanced controller. It doesn't require DSP or FPGA if control complexity is less. But if control complexity is more, we don't have any option. If you want to execute your complex logic, it required high-end processor. DSP or FPGA boards are required. Right? Clear? Now, one more important question. See, many scholars they are getting confused how to generate the torque. What is the basic principle? If you take the nature of the torque, in case of DC machine or AC machine or special purpose machine is same. If you want to generate the torque, you have to satisfy one important constraint. There is one important constraint is there, you need to satisfy. What is that important constraint? If you want to produce the twisting force in motoring mode, what is the essential thing? Otherwise, I want to ask one more. Take generator, motor, right? What is the expected output of the generator? Voltage, right? What is the expected output of the motor? Torque, right? Clear? These two are called potential element. These two are called force component. See, this component is so important whenever you want to do job in electrical circuits. Using this component, we can drive the electrons. We can do job in electrical circuits, right? Using this component, we can do job in mechanical circuits. These two are called potential elements to do the job, right? So that's why these two are called causal components in the electrical circuit as well as mechanical circuit. If you want to produce voltage, it required torque, load torque, prime mover is required, right? If you want to produce the torque, it required electrical force. See, if according to Newton's law, whatever job you want to do, if you want to change the state of the objective, it requires force. Without applying any force, we cannot do anything. Here also, in motoring case, right? See, if you want to control the torque, you need to control through voltage. We don't have any option. This voltage signal will come from the digital controller. This digital controller will produce the control pulse to the power semiconductor device. Power semiconductor device will produce the variable voltage as well as variable frequency to the motor. By adjusting the voltage as well as frequency, right, immediately torque will get affected. So once torque is getting changed, immediately torque is the main cause component to change the speed of the shaft, right? So immediately your speed will change, right? Once speed is getting changed, automatically what will happen? The position of the shaft will vary. Now, as an electrical scholar, see, whenever you want to design a controller, important thing is you need to identify what is the cause and effect relationship for a particular system. You have to identify. So our topic, our objective is understanding the advanced control schemes for electric drive. So these two parameters are so important with respect to application point, with respect to customer point. In aerospace application, robotic application, right? Even if you take satellite application, position control is so important. Their requirement is position control. In EV application, with respect to customer point of view, speed is important parameter. If you want to satisfy position or speed requirement only as a controller, you have to target. What is the target parameter? Torque. By controlling the torque as a controller, see, first you need to identify what is the required amount of position or required amount of the speed with respect to customer point of view. You have to get the information. Once you know the information as a controller, it is not a big deal to control the torque. By controlling the torque, we can control the speed as well as position. But torque is controlled through power semiconductor element. Why? Because torque is a function of voltage. Clear? Now, see, these two are so important parameters, voltage and torque. Now, there is a universal concept is there. If you want to produce a twisting force or if you want to produce the electrical force, see, there is a constraint is there. You need to satisfy. There is no option for us, right? If you want to get finite voltage or finite torque, you need to satisfy important constraint. With respect to voltage, what is the important constraint to produce the voltage? Anyone?